For example, my name is Sonamchoki. Today, me and my friend Yingtin Jamso, we will be performing a practical together. The topic of our practical is equivalent circuit of three-phase induction motor. We will be performing two tests, which is no-load test and block rotor test. The no-load test for the induction motor is similar to the open circuit test of the transformer. It provides information about the magnetizing branch and the rotational loss of the machine. The test is done by applying rated frequency and voltage to the stator windings with no load on the shaft of the machine. Voltage, line current, and power ratings are noted while performing the practical. The power at no load P0 is the sum of rotational losses, copper losses of the stator, and core loss. Rotational losses can be measured by driving the motor at a rated speed with no voltage applied. The block rotor test is similar to the short circuit test of the transformer. During this test, the rotor is physically restrained so it cannot turn. Because the speed of the rotor is 0, the slip is 1. This test is done at just enough voltage to provide the rated current, hence the block rotor test is also termed a short circuit test. In this test, the power factor is lagging but improves due to increasing in the active power, which causes the active component of the current to increase accordingly while the reactive current component remains fairly constant. This test is done to determine the short circuit current with a normally applied voltage to stator power factor on short circuit, total equivalent resistance and reactance of the motor as referred to the stator. The aim of this practical is to perform no-load and block rotor test on three-phase induction motor and calculate all the motor parameters and determine its efficiency at full load and 50% of full load condition. The objective of the practical is to determine the relationship between applied voltage and input power, applied voltage and stator current, applied voltage and rotor current, applied voltage and the current. Materials required for the practical are a three-phase power supply, two 0 to 350 watt wattmeter, two 0 to 500 AC voltmeter and 0 to 5 AC ammeter, a tachometer to measure the speed, and an induction motor with 380 volt and 2.35 ampere, and some 2.5 mm square connecting wires. The circuit connection is done following the circuit diagram. Here 2 wattmeter method is applied. An AC voltmeter is connected to the supply to measure the input voltage. From the supply, the red phase is connected to the M side of the first wattmeter, and from the L side, it is directly connected to the ammeter, and from there it is connected to the induction motor. The yellow phase from the supply is connected to 150 volt of first wattmeter, and then it is shorted to 150 volt of the second wattmeter. From there it is directly connected to the induction motor. The blue phase is connected from the supply to the M side of the second wattmeter, and from the L side of the second wattmeter it is directly connected to the induction motor. After the connection is done, give the supply. Turn on the MCB and the RCCB. We can now perform the no-load test. These are the readings we need to record, which are stator current, speed in RPM and the 2 wattmeter. And to calculate the power factor, we need to use this formula. Turn on the power supply and increase the voltage from 0 to 25% of the rated voltage, which is 95 volt. Record the readings of the first wattmeter and then the second wattmeter. The wattmeter is connected in series, which means 5 ampere, and the voltage is 150 volt, so the multiplying factor is 1. Record the stator current reading and also the speed of the motor with the help of tachometer. Record the reading till you get the rated voltage. Next is our observation table. We got 4 readings till our rated voltage. For the calculation, we first find the power factor. Using that, we find the energy component and the magnetizing component. From there, we find no load resistance and no load reactance. Next, we will be performing block rotor test. In this test, the rotor is clamped by hand, so it cannot rotate. These are the readings that needs to be recorded in this test, which are stator voltage and the 2 wattmeters. Turn on the supply again. Increase the voltage till you get the rated current. The rated current is 2.3 ampere. After getting the rated current, record the stator voltage. Then record the second wattmeter reading and the first wattmeter reading. You can continue by reducing the stator voltage, hence reducing the stator current. Next is our observation table. These are the readings that we got. We continue till 25% of the rated current, which is 0.6 ampere. For the calculations, we calculate resistance and impedance, and using the formula Z square minus R square, the whole square root, we find reactance. Now we can turn off the power supply. Slowly reduce the voltage and turn off the supply. We can now draw the equivalent circuit. The parameters we need to draw the equivalent circuit are resistance and reactance of no load and block rotor test. We also need no load current, magnetizing current and active current of no load test. The resistance and reactance we got from the block rotor test is connected in series. The reactance we got is 20.66 and resistance is 9.135 ohm. The no load current we got from no load test is 2.1 ampere. The resistance value is 193 ohm. And the reactance value is 124.159 ohm. The resistor and the inductor are connected in parallel to each other. The no load current gets divided in the parallel connection with the active current flowing across the resistor and the magnetizing current flowing across the reactance. This is our equivalent circuit. The precaution for this practical is, on no load test, the voltage should not exceed beyond its rated value of motor. On the block rotor test, the voltage should be applied gradually till the motor reaches its rated current. In the block rotor test, the rotor should be stationary. While in the block rotor test, the rotor was stopped by using a hand to act as a load. But in big industries, where the rotor is very big, hand cannot and should not be used as a load. For the conclusion, at no load, the current drawn by the induction motor is small, while in the block rotor test, the current drawn by the motor is high. The no load test and block rotor test can be used to determine the power factor, power input, and the equivalent circuit of 3-phase induction motor. Thank you.